So hopefully you wrote something down for your reflection on what you needed to do for 9.1. Now let's move on to 9.2 to 9.3, which is just graphing our different simple, general, and more complex rational functions. So for each of these, we need to list all of our important parts and then graph each function. So let's do that. So our first step when we're doing these is to see if we can simplify. And if you notice, we have a 4x plus 12 on the bottom, so the bottom can be factored to 4 times x plus 3. And then we have our 2x in our numerator. So if we wanted to, we can simplify the 2 and the 4. So that would give us x all over 2 times x plus 3. Alrighty, so to find our vertical asymptote, since we have an x on top and we just have an x on the bottom, all we do is we set our denominator equal to 0. So when we do that, we'll have a x2 times x plus 3 equal to 0. When we solve, we divide by 2. So 0 divided by 2 is 0. So if x plus 3 equals 0, that'll give us a vertical asymptote of x equals negative 3. Our horizontal asymptote, since we have an x on top and x on the bottom, they have the same degree. So we just look at the coefficients of those x's. So that's just 1 on top, 1 on top and 2 on the bottom. So that would give us a y value of 1/2. Then to look at our wholes, we need to say, okay, well, did we cancel any factors out? Well, we canceled out this 2 here, but that's not the same thing. When we're looking at a whole, we're looking what x did I cancel out. So since we didn't cancel any x out, we do not have any wholes. So next we need to look at our domain and say, okay, well, what can x not be? So we know for sure we can't have an x value of negative 3 since we have a vertical asymptote there. Means we don't have an x value of negative 3. But do we have any other restrictions? Nope, we don't. So that means it could be all real numbers, but x cannot equal negative 3. And for a range, it's the same thing. We can have all real numbers, but our y value, since we have a horizontal asymptote of 1/2, our y value cannot equal 1/2. Alright, and then to find our x-intercepts, that's where our graph touches our x-axis. That would be setting our y value to 0. So to do that, a shortcut is just to set our numerator equal to 0. Our numerator is x, so that would mean our x would have to be 0. So that would just give us a point of 0, 0. And then to find our y-intercept, we set our x equal to 0. And when we do that, I'll show the work over here. We'll have 0 over 2 times 0 plus 3, which gives us 0 over 2 times 3 is 6. 0 divided by anything is 0. So that gives us a y-intercept of 0, 0. Notice that these are the same points. Alrighty, so then let's graph what we know. We have a domain of, or a vertical asymptote of x can equal negative 3, or x equals negative 3, excuse me. Horizontal asymptote of y equals 1/2. We have a x and y intercept of just 0, 0. So then from here we have to find 3 points to the left and 3 points to the right of our vertical asymptote. So I want you to plug this original graph into your calculator, find 3 points to the left and 3 points to the right, write those out, and plot those points. Alright, so pause the video and do all of that and then compare with what I have. So this is what you should have. Once you look on your calculator, you should have these 3 points for the 3 points to the left and these 3 points, or possibly 4 points, to the right of our asymptote. If you look on your calculator for x is negative 3, you will have an error message. That's because we have a vertical asymptote there. So let's look at our last problem. Now, if you look at this, it looks kind of crazy, but what I want you to do is try to see if you can simplify this, alright? So we have our 4 different factors. See if you can simplify this on your own. So pause the video, try and factor this. We have an a value of greater than 1, so you'll have to use the Batman method and look to see if you can factor anything else and see what you can cancel, so that way you can have your final rational fraction or rational function. Alright, so pause the video, see what you can do. Alright, so looking at our final equation, we should have only a 1 over 4x minus 3. Because this first factor, use the Batman method, you should get 4x plus 3 and times x plus 2. And this factor we can't do anything with, that does not simplify. But this bottom, that's a difference of squares, so we get 4x minus 3 times 4x plus 3. And then our last one, this is a sum of 2 cubes, so we need to use our SOAP method, and then we just cancel stuff out. So once we do that, we should get 1 over 4x plus 3. So to get our vertical asymptote, we just set our denominator equal to 0. So once we do that, we should get an x equaling 3/4, which if we wanted to rewrite that, we could do that. X equals 0.75. A horizontal asymptote. Since we don't have an x on the top, we have an x on the bottom. That means our horizontal asymptote is going to be just y equals 0, because we have a greater degree on the bottom. For our holes, we have to look at everything that we canceled out and set that equal to 0 and plug that back into our original equation. So we have 3 different things that we canceled, so we're going to have to look at each of those 3 different parts. So I'm going to do that down here. So I'm going to start with my 4x plus 3. So my 4x plus 3, set that equal to 0. So that gives us a 4x equals negative 3. Which gives me an x equals negative 3/4, which is a negative 0.75. So then from here, I need to take this negative 3.75 and plug that into my new original equation. So when I do that, that will give me a value of 1 over 4 times negative 3/4, or negative 0.75. That is negative 3, so minus 3. And then that would give us a value of, a y value of 1 over negative 6. So together that gives us the point of negative 0.75, comma, negative 1/6, which 1/6 as a decimal is 0.17. Okay, so let's look at our next whole of x plus 2, set that equal to 0. So we should get x value of negative 2, so plug that into your original equation, and you should get 1 over 4 times negative 2 is negative 8, minus 3, so that's negative 1 over 11, which that as a decimal is roughly 0.1, negative 0.1, excuse me. So then that would give us a second whole as negative 2, negative 0.1. And then we have our third thing that we crossed off, x squared minus 2x plus 4, set that equal to 0. Since this doesn't factor, we'll have to use the quadratic formula, so that is our opposite of b, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 4, all over 2a. So we should notice when we take the square root, we get 4 minus 16, so that's a negative 8 all over 2. Since we have a negative under the square root, that gives us an imaginary number, so that means this does not give us an actual point on the graph. So we are not going to have a whole from this factor because it gives us an imaginary solution, which that will not be seen on our graph. So then now we can look at our domain. So for this, we have to say, well, what can x not be? Well, we know we have a vertical asymptote of 0.75, so we're going to have all real numbers, but x cannot equal 0.75. But we also know x can't equal either one of these values because those are both holes in our graph. So that gives us a negative 0.75 and a negative 2. And same for the range, we have all real numbers, but we have a horizontal asymptote at 0, so that means y can't be 0. Y also can't be negative 0.17 or negative 0.1 coming from our y variables, or not y variables, y coordinate for our holes. Then to find our x-intercept, just like before, we set our numerator equal to 0. When we do that, we get 0 equals 1, so that means we don't have any x-intercepts. And then to find our y-intercepts, we set our x equal to 0. So when we do that, that gives us a 1 over 4 times 0 minus 3. So that gives us a negative 1/3, which is roughly negative 0.33. So that would give us the point 0, comma, negative 0.33. So from here we can plot all these points and asymptotes on our graph. So we have vertical asymptote at x equals 0.75, so that's here. We have a horizontal asymptote of y equals 0. We have holes at negative 0.75, comma, negative 0.17, so that would be roughly here. We have another hole at negative 2 and negative 0.1, so that's roughly here, just a little bit higher to the x-axis. And since we don't have any more holes, we can just start plotting our intercepts. So we don't have any x-intercepts, so we have a y-intercept of 0, negative 0.33, so that's roughly here. So from here you can plug in your original equation, so this whole thing, into your calculator. Make sure the biggest thing is that you need to put a whole set of parentheses on the top and a whole extra set of parentheses on the bottom. So plug in your 3 points. Well, look at your 3 points to the left and to the right of your asymptote, and then write them down and plot them on your graph, and then compare with what I have here. Alright, so these are the 3 points that you should have to the left of your asymptote and 3 points to the right. I didn't include an x value of negative 2 because there's a hole there, so I just skipped over that. So make sure the biggest thing is that you don't draw a line through your holes because those points aren't on your graph. Okay, so I want you to now reflect. What do you need to remember about 9.2 through 9.3 to do well in the quiz? Alright, write down 3 things here, and that is it. I will see you in class tomorrow.